Dear students, welcome to Mathematics Online classes. We are going to solve example 36 in the integrals. This will be the last example. It is given as I is equal to integration of log of sin x with respect to x from 0 to pi by 2, 0 to 90 degree. How will you solve it? Log of sin x it is. Here let us use the property of, I am using the property here, integrating from 0 to a, it is in the form integrating from 0 to a f of x with respect to x is equal to integrating from 0 to a f of a minus x into dx it is. Okay, I will use that property. Let me take this as equation 1 and now I is equal to integrating from 0 to pi by 2 log of sin of pi by 2 minus x into dx it is. Log of 90 minus x is cos x, log of sin of 90 minus x is log of cos x. Yes, it is log of cos x into dx from 0 to 90 degree, that is 0 to pi by 2. Let me take this as equation 2. Now adding equation 1 and 2, left hand side I plus I become 2i. 2i is equal to integrating from 0 to pi by 2 log of sin x into dx plus of integrating from 0 to pi by 2 log of cos x into dx. Now I have 2i is equal to, see here it is sum of two integrals. We will write it as single integral. Integral is 0 to pi by 2, 0 to pi by 2 here. Yes, 0 to pi by 2 log of sin x plus log of cos x into dx. Now you see this function is in the form of log m plus log n, that is log m plus log n. Log m plus log n is equal to, we know the formula as log of m into n plus. Now we have here 2i is equal to integrating from 0 to pi by 2 log m plus log n. Log mn we are going to write log of sin x into cos x into dx. Yes, we have 2i is equal to, now what I do here 0 to pi by 2, keep this as it is, log of sin x into cos x is there now, we will write it as 2 sin x into cos x by 2. We are multiplying with 2 and dividing with 2, no changes at all. Yes, with this you see it is in the form of log m by n. Log m by n is equal to, we know it as log m minus log n. Using this formula we write here 2i is equal to integrating from 0 to pi by 2 log of 2 times sin x into cos x minus log n, it is log 2. Whole integral is with respect to x. This is 2i is equal to integrating from 0 to pi by 2 2 sin x into cos x, it is nothing but sin to x, first standard means first year formula, log of sin to x. Let me write it as sum of two integrals into dx minus of integrating from 0 to pi by 2 log 2 into dx. Yes, now here you see this integral, to integrate it, if you do some modification here, it is in the form of a log sin x again. Okay, let us what to do, before simplifying this let me integrate this. 2i is equal to integrating from 0 to pi by 2 log of sin 2x into dx. Log 2 is a constant value, constant multiple, we will write it out of the integral. We left with integration of 1 with respect to x. Integration of 1 with respect to x is x, lower limit 0, upper limit pi by 2. Now we will go on substituting with this, we left with only one integral here. In this integral, we will substitute some value t is equal to 2x. Let me substitute t is equal to 2x here. Then what is dt is equal to, dt by dx is equal to 2. We have only dx here, then dt 1 by 2 into dt is equal to dx. What happens to the upper limits and lower limits? When x is equal to 0, lower limit t is also 0, and upper limit when x is equal to pi by 2, t is equal to 2 into pi by 2. 2 to get cancels out, we have pi here. Yes, this is 2I is equal to integration of 0. In place of pi by 2, it become pi log of sin 2x is t, log of sin t, dx is 1 by 2 into dt, 1 by 2 I will write outside into dt. Now minus of log 2 into, here substituting the upper limit, that is pi by 2, minus substituting the lower limit, that is 0. We have 2I is equal to 1 by 2 times integrating from 0 to pi log of sin t into dt is there now, can be written as log of sin x into dx. Just I am changing the variable because using the property remaining is minus log 2, minus of pi by 2 into log 2. Here I am using the property integrating from a to b f of x into dx is equal to integrating from a to b f of t into dt. That one I am doing. Yes. Next you see, in this it is in the form, 0 to 2a f of x into dx is equal to, if I consider this 0 to 2a, let me check whether this property is valid or not. 0 to 2a f of x into dx is equal to, I have two cases. One is 2 times integral from 0 to a f of x into dx, if f of 2a minus x is equal to plus f of x, it is 0 if f of 2a minus x is equal to minus f of x, we know this. Then here we see f of x is equal to log of sin x, then f of, in place of pi, what is there, pi is there, f of pi minus x is equal to log of sin of pi minus x. This is log of sin x only, log of sin of pi minus x is there, pi minus x, 180 minus x, sin is positive, this become sin x only, nothing but f of x. Then among these two, which one to use? This first case should be used here. Now 2I is equal to 1 by 2 times, 1 by 2 is a constant multiple, it will be outside. I am using that property, that becomes 2 times integrating from 2a means pi, so a is equal to pi by 2. 2 times integral from 0 to pi by 2 log of sin x into dx minus of pi by 2 into log 2. Yes, 2 to get cancels out. 2I is equal to, you see, 0 to pi by 2 log sin x into dx is nothing but I minus of pi by 2 into log 2. I will come to the left hand side, 2I minus I is equal to minus pi by 2 into log 2. 2I minus I is equal to minus pi by 2 into log 2. You can leave it here, minus pi by 2 into log 2, or we can simplify it further. See, what is log of 1 by 2? Log of 1 by 2 is in the form of log of m by n. Log of m by n is equal to log m minus log n, means here log 1 minus log 2. What is log 1 value? Log 1 value is 0. So 0 minus of 1 into log 2. What I have? I am getting log of 1 by 2 is equal to minus log 2. Here also you see pi by 2 into minus log 2 I can write. This is pi by 2 into log of 1 by 2. I is equal to, this is what the integral is. With the usage of properties we can solve. Yes, with this examples on properties of definite integrals completed. We will move on to the exercise on properties of definite integrals. Exercise 7.11. By using the properties of definite integrals, evaluate the integrals. Using the properties is must. Yes. Now, under that, equation 1, it is given integration of cos square x, integration of cos square x with respect to x from 0 to pi by 2. See, if it is given in case of indefinite integrals, how we integrate it? Integration of cos square x. We integrate it using the formula for cos 2x. Cos 2x is equal to 2 times cos square x minus 1. That formula we will use and we integrate it. Here, in a very simple steps we can integrate it. I is equal to integration of cos square x with respect to x from 0 to pi by 2, and let me take this as equation 1. Now, I will use the property that is using integration of f of x with respect to x from 0 to a is equal to integration of f of a minus x with respect to x from 0 to a. Now, I is equal to integration of cos square pi by 2 minus x into dx from 0 to pi by 2. I is equal to integration of cos square 90 minus x. Cos 90 minus x is sin x. Square is there, that become sin square x into dx. This upper limit and lower limit will be as it is. Take this as equation 2. Now what you do? Taking equation 1 plus equation 2. Left hand side I plus I, 2i is equal to right hand side 0 to pi by 2 cos square x into dx plus of 0 to pi by 2 sin square x into dx. Then we have 2i is equal to integral from 0 to pi by 2, writing it as single integral. This become cos square x plus sin square x into dx. We know the formula cos square theta plus sin square theta is equal to 1. Yes, we have 2i is equal to integration of 1 with respect to x from 0 to pi by 2. 2i is equal to, what is integration of 1 with respect to x? It is x 0 to pi by 2. So, it is pi by 2 minus 0. 2i is equal to pi by 2, I is equal to pi by 2 into 2, this become pi by 4. So, answer is pi by 4. With this, first question in the exercise 7.11 completed. Second problem is integration of square root of sin x by square root of sin x plus square root of cos x into dx from 0 to pi by 2. Directly we can say this answer, it is pi by 4. Using the steps what I have followed for the previous problem, you follow the same thing, you will get the answer. Now I will move to the next. Question number 3 also. Question number 5, question number 3, just the power is difference there. Question number 3, it is given integrating from 0 to pi by 2 sin to the power of 3 by 2 into x by sin raised to 3 by 2x plus cos raised to 3 by 2x into dx. Very simple, it is same way as we did in the previous. I is equal to integration of sin raised to 3 by 2x by sin raised to 3 by 2x plus cos raised to 3 by 2x into dx from 0 to pi by 2. Take this as equation 1. Then you use the property using integrating from 0 to a f of x into dx is equal to integrating from 0 to a f of a minus x into dx. Now I is equal to integrating from 0 to pi by 2 sin raised to 3 by 2 into pi by 2 minus x here. Everywhere x become pi by 2 minus x. This is sin raised to 3 by 2 into pi by 2 minus x plus cos raised to 3 by 2 into pi by 2 minus x into dx. We have I is equal to integration of sin raised to 3 by 2 pi by 2 minus x. Power let it be whatever. Sin of pi by 2 minus x is cos x. So cos of same power whatever is there. This is cos raised to 3 by 2 into x divided by denominator also cos raised to 3 by 2 x plus sin raised to 3 by 2 x into dx, integrating from 0 to pi by 2. Take this as equation 2. Yes, from 1 and 2 what I can write? From 1 and 2 in the sense adding 1 and 2. Adding 1 and 2. I plus I is equal to 2i. See, right hand side 0 to pi by 2, 0 to pi by 2, two integrals will be there. I am writing in a single step. 0 to pi by 2, first one is sin raised to 3 by 2x by sin raised to 3 by 2x plus cos raised to 3 by 2x plus of function in the second integral cos raised to 3 by 2x plus cos raised to 3 by 2x plus sin raised to 3 by 2x, integrating with respect to x. 2i is equal to integrating from 0 to pi by 2, denominators are same here. We have sin raised to 3 by 2 into x plus cos raised to 3 by 2 into x. Same way numerators will get add up sin raised to 3 by 2x plus cos raised to 3 by 2 into x. Whole integral is with respect to x. These two are same, get cancels out. We have 2i is equal to integration of 1 with respect to x from 0 to pi by 2. 2i is equal to integration of 1 with respect to x is x from 0 to pi by 2. Yes, 2i is equal to substituting the upper limit and lower limit, that becomes pi by 2 minus 0. We have pi by 2. Then I is equal to pi by 2 into 2. So I is equal to pi by 4. This is about problem number 3. Now in the exercise 7.11, let us take question number 4. Question number 4 is similar to the questions I have solved. 0 to pi by 2 sin raised to 5x by sin raised to 5x plus cos raised to 5x into dx. Same way I equal to, that is equation 2, equation 1, use the property 0 to a f of x into dx. You solve it, we will get the answer as pi by 4. I will take the question number 5. Question number 5 is integration of modulus of x plus 2 with respect to x from minus 5 to plus 5, from minus 5 to plus 5 into dx. Okay. Here integrating from minus 5 to plus 5, modulus of x plus 2 is there. Again it comes to the integration of modulus functions. Integration of modulus functions, let me explain here. Modulus of x plus 2 is equal to, we have it as plus of x plus 2 and minus of x plus 2 depending on the condition, like when x plus 2 is greater than or equal to 0, when x plus 2 is less than 0. This is equal to x plus 2 when x plus 2 is greater than or equal to 0 means x is greater than or equal to minus 2. This is minus of x plus 2 when x is less than minus 2. So, modulus of x plus 2 is equal to, we should take plus of x plus 2 when x is greater than or equal to minus 2, means minus 1, 0, all those values will come. And we should take modulus of x plus 2 is equal to minus of x plus 2 when x values are less than minus 2. Now, we are integrating it from minus 5 to plus 5, here is 0, minus 5 to plus 5 we are integrating. See, somewhere here will be the minus 2, and now you see minus 2, minus 5 to minus 2, minus 5 to minus 2, in this interval x values are less than minus 2. So, which function will come? Minus of x plus 2 will come. Next, minus 2 to 5, minus 2 to 5, x value is greater than minus 2, x value is greater than minus 2 means plus of x plus 2 will come. So, our integral, integrating from minus 5 to 5 modulus of x plus 2 into dx is equal to, we will split it into sum of two integrals. One integral is from minus 5 to minus 2 and second integral is from minus 2 to 5. Minus 5 to minus 2 modulus of x plus 2 into dx plus minus 2 to 5 modulus of x plus 2 into dx. Now, integration of means integrating from minus 5 to minus 2 modulus of x plus 2 is equal to, which one I have to take? I have to take it as minus of x plus 2. This is minus of x plus 2 into dx. Now, when we integrate from minus 2 to 5, we have to take it as plus of x plus 2, plus of x plus 2 into dx. Now, it is very easy to integrate. Minus, let it be outside, minus is a constant multiple. Integration of x with respect to x is x square by 2 plus integration of 2 with respect to x is 2x, minus 5 to minus 2 plus of, now here x square by 2 plus 2x from minus 2 to 5, minus, let it be outside, substituting the upper limit, this become minus 2 square, minus 2 square means 4, 4 by 2, 2 into minus 2 is minus 4. Okay. This is substituting upper limit, minus of substituting the lower limit, because minus is multiple to both the terms, we have to be careful here. Now, substituting the lower limit minus 5 whole square is 25 plus 25 plus 25 by 2. Now, 2 into minus 5 is minus 10 plus of, next substituting the upper limit here, 5 I am substituting 2 square 5 square 25 by 2 plus 2 into 5 10 minus of, substituting the lower limit, minus 2 square you substitute, minus 2 square is 4, 4 by 2, 2 into minus 2 it is minus 4. Yes, simplifying it, minus of, minus completely outside, let it be minus of 4 by 2 is 2, 2 minus 4, minus will get multiplied with these two, this become minus 25 by 2 and plus 10, and now second one 25 by 2 plus 10, minus will get multiplied with these two, 4 by 2 is 2, minus 2 plus 4. That says here minus of, the here equal to is that minus of 2 minus 4 minus 2 plus 10 plus 8 minus 25 by 2 plus of, here 25 by 2. This is 10 minus 2, 8, 8 plus 2, 8 plus 4, 12. Yes, minus will get multiplied with this, minus 8 plus 25 by 2 and plus of, here it is 25 by 2 plus 12. I will cross multiply, minus 16 plus 25 by 2 it is, plus of, this is 25 plus 24 by 2, minus 16 plus 25, this is plus 9 by 2 and plus of, here 25 plus 24, it is 49, 49 by 2. 2 is the LCM, 9 plus 49, 58, 2 ones are 2 twos are 1 will be there, 18, 19. So answer is 29. With this, question number 5 completed. Now I will move to question number 6. Question number 6 is integrating from 2 to 8 modulus of x minus 5, modulus of x minus 5 into dx. Modulus of x minus 5 is equal to, again according to the modulus function definition, it takes two functions. Modulus of x minus 5 is equal to plus of x minus 5 when x minus 5 is greater than or equal to 0. It is minus of x minus 5 when x minus 5 is less than 0. Okay. We have here plus of x minus 5 when x minus 5 is greater than or equal to 0 means x is greater than or equal to 5. It is minus of x minus 5 when x minus 5 is less than 0, that means x is less than 5. Yes, you see here we are integrating, if it is a number line 0, this side positive values, this side negative values, somewhere here will be the 5 and somewhere here will be the 8 and here is 2. We are integrating from 2 to 8. Integrating from 2 to 8 we should not have the single function, because from 2 to 5, in the interval 2 to 5, x values are what? X values are less than 5. Which function to choose? We should choose minus of x minus 5. Next, this 5 to 8. In this 5 to 8, x values are greater than 5. So, modulus of x minus 5 is equal to plus of x minus 5. Yes. Now, integrating from 2 to 8, modulus of x minus 5 is equal to, x minus 5 into dx is equal to, we will split it into sum of two integrals. First one is 2 to 5 modulus of x minus 5 into dx plus of, next one is 5 to 8 modulus of x minus 5 into dx. Now, integral of modulus of x minus 5, plus we should take or minus we should take, 2 to 5, x values are less than 5, you know, so minus of x minus 5, that minus I will write outside into dx, this is 2 to 5, plus of 5 to 8, 5 to 8 x values are greater than 5, so function should be taken as plus of x minus 5, minus of x minus 5 integral x square by 2 minus 5x, it is 2 to 5, plus of, next here also same thing, x square by 2 minus 5x, 5 to 8, minus of, substituting the upper limit, 5 means it is 25 by 2, minus of 5 into 5, 25, upper limit substitution over, minus of substituting the lower limit, 2 square, it is 4, 4 by 2, minus of 5 into 2 is 10, plus of, next substituting the upper limit, 8, 8 square is 64, 64 by 2, minus 5 into 8 is 40, minus of, substituting the lower limit, 5 square is 25, 25 by 2 minus 5 into 5 is 25. Minus of 25 by 2 minus 25. 25 minus 50 by 2 cross multiplying, and minus of 4 by 2 is 2, minus will get multiplied, minus 2 plus 10 it become. Next, second one, plus of 64 by 2 is 32, 32 minus 40 and minus will get multiplied, minus 25 by 2 and plus 25 it is. Here we have minus of 25 minus 50 minus 25 by 2, minus 2 plus 10 is plus 8, plus of 32 minus 40 is minus 8 minus 25 by 2 plus 25. Here minus outside, cross multiply it, minus 25 plus 16 minus 25 plus 16 plus of, here it is 2 will be the LCM, minus 16 and this is minus 25 plus 50, minus of minus 25 plus 16 is minus 9, minus 9 by 2 plus of, this is again you see plus 9 by 2 it is, minus minus plus 9 by 2 plus 9 by 2, 9 by 2 plus 9 by 2 is 2 times 9 by 2, answer is 9. Okay, this is about question number 6. Let me take question number 7. Question number 7 in the exercise 7.11 is integration of x into 1 minus x whole raised to n into dx from 0 to 1. Very simple it is. Let me take I is equal to integration of x into 1 minus x whole raised to n into dx from 0 to 1. Now what I do, I will use the property using integration of f of x with respect to x from 0 to a is equal to integration of f of a minus x with respect to x from 0 to a. Then I is equal to integrating from 0 to 1. Here a is there, x become a minus x. Now here 1 is there, x become 1 minus x. 1 minus of 1 minus x whole raised to n into dx. I is equal to integrating from 0 to 1. We have 1 minus x into this, inside the bracket become 1 minus 1 plus x. Plus 1 minus 1 get cancels out. We left with only x there, x that power is n, x raised to n into dx. I is equal to integrating from 0 to 1. This x raised to n will get multiplied with these two terms. This is x raised to n minus of x into x raised to n is x raised to n plus 1 into dx. I is equal to, now we can integrate it very easily. Integration of x raised to n is x raised to n plus 1 by n plus 1 minus of x raised to n plus 1 integration is x raised to n plus 1 divided by n plus 1 plus 1 means x raised to n plus 2 by n plus 2. This is integrating from 0 to 1. Okay, now we will substitute the upper limit in place of x 1 to the power of anything is 1 only, 1 by n plus 1 minus of, this is 1 by n plus 2 minus of 0 minus 0 it is x 0. Yes, 1 by n plus 1 minus 1 by n plus 2. Simplify this, cross multiplying n plus 2 minus n minus 1 divided by n plus 1 into n plus 2. So n get cancels out, 2 minus 1 1, 1 by n plus 1 into n plus 2 it is, I is equal to. This is about question number 7. Now question number 8 onwards we will take it in the next video. Thank you.